Welcome to Honey of Knowledge. This is Ashish Gaurav, and today let's discuss something about equilibrium in social interactions. Do you remember the movie A Beautiful Mind? Yeah, John Nash movie. So in that movie, there's a scene in which three, four friends are sitting and discussing whether to approach a blonde, beautiful woman or not. And John Nash, who was among them, suddenly had an epiphany. And the epiphany was like this, that why should we approach the blonde woman? She is anyway above their league. So let's approach the other girls and make our chances high. Now, a lot of people, after watching this, think of this as a Nash equilibrium, but it's not. Because if you remember what's Nash equilibrium, it's a situation in which the strategic interaction of players or agents is such that none of the agents can single handedly or unilaterally deviate from that situation to benefit. Or rather, if let's say you have five players playing a game, and if four of them, any four of them, do not change their strategy or decision or way to play, the fifth person, if he can deviate and benefit, then it is not a Nash equilibrium. But if he is not able to benefit after deviating, it is a Nash equilibrium. So essentially, it's a case of no unilateral profitable deviation or no single-handed profitable deviation of n players or any number of players. So let's simplify the John Nash situation or a beautiful mind scenario. So let's say you have three friends and they are putting 50 value. I mean, tend to think in terms of utility in economics, but let's say it's some kind of a notional value, 50, when they approach a blonde woman and she accepts their proposal. And similarly, a utility or a notional value of 10 is attached to approaching another girl and she accepting their proposal. So how can you model this? Now let's take rest of the friends as one agent. Now this is a very vague kind of a thing and not uh, a perfect way to represent Nash equilibrium situations or game theoretic models, but we will take this just for the time being. And this represents John Nash. So let's say all of them approaches blonde, and even John Nash's approaches the blonde. Now, obviously, as per John Nash's theory, nobody will get the blonde. So 0, 0. Now, idea here is you need to understand how this matrix is. The first number corresponds to the rest of the friends, and the second number corresponds to John Nash. So if you check this situation, when the rest of the friends are going to the blonde, but John Nash is avoiding the blonde, so it is 0, 10, or rest of the friends get 0 and John Nash is getting 10. Now let's take another situation. When rest of the friends are avoiding blonde and John Nash is also avoiding the blonde, in that case they're approaching other girls. Now if they're approaching other girls, they get a utility of 10. So John Nash will get 10 and the other folks will get 10 each. So 10 plus 10, that will be 20, because we have two friends apart from John Nash. Now let's say we take the situation of John Nash avoiding the blonde, John Nash going to the blonde, and other folks avoiding the blonde. So if other folks are avoiding the blonde, they will get 10 each. So 10 plus 10, 20. But John Nash, being the single person approaching the blonde, will definitely be accepted, and he will get a 50 reward, or rather a 50 notional value. Now over here, I claim that this is the Nash equilibrium. John Nash going to the blonde and rest of the friends avoiding the blonde. Uh, but anyway, the Nash equilibrium quoted by John Nash in the movie, which is avoiding the blonde by all of them, even John Nash, is certainly not Nash equilibrium. Let's see how. This 20, 10 is the touted equilibrium in the movie. Now, let's consider John Nash, and rest of the friends are staying put at their decision of avoiding the blonde. Now, very simply, John Nash can jump from avoiding the blonde to going to the blonde and get a benefit of 40, 10 to 50, because he is moving horizontally. None of the other players are moving. So the game goes from 20, 10 to 20, 50. So this is how John Nash can benefit from uh, deviating from this touted Nash equilibrium of everybody avoiding the blonde. So certainly the movie is not accurate if they want to show that this is a Nash equilibrium. But I don't think the movie showed that. Only few people who are enthusiastic, they uh, describe it as a Nash equilibrium. So let's go to a proper example of a Nash equilibrium. Let's suppose you and your friend want to watch something together. Let's say you have decided that either you will watch Game of Thrones, GOT, or How I Met Your Mother, HIMYM. Now, you love Game of Thrones, but your friend is a How I Met Your Mother kind of a person. So, definitely, both of you are not in the same page. And there could be situations where you would like to watch individually, but you are together at a place and want to watch it on a single screen, not separate devices. So let's think of it. So if both of you watch Game of Thrones, you love Game of Thrones. So let's say you get a notional value of 70, but your friend does not like that. He gets only 30. Now, let's suppose you watch Game of Thrones and your friend watches How I Met Your Mother. Now, both of you are watching on different screens. So, both of you get a reduced payoff. You from 70 to 30, and your friend goes from 30 to 20. Now, we can do the same for How I Met Your Mother. If you are watching How I Met Your Mother and your friend is watching Game of Thrones, now obviously this is not going to happen in any way because you do not like How I Met Your Mother and your friend does not like Game of Thrones. But just to complete the matrix, let's construct this. Now, if both of you watch How I Met Your Mother, your friend will get a very high reward of 40 and you will get a slightly less reward of 20. So over here, what is the Nash equilibrium? Now it's very simple to see that both of you watching Game of Thrones is a Nash equilibrium because you value Game of Thrones very high. Let's see how. Now, if your friend is not deviating from Game of Thrones, so obviously you're better off watching Game of Thrones because if you move to How I Met Your Mother, suddenly you go from 70 to 5. So you don't have a profitable deviation. Now, let's say you watch Game of Thrones and your friend wants to watch How I Met Your Mother. Now, if he does that or she does that, he or she will go from 30 to 20. So, obviously, even your friend does not have a profitable deviation, which means 70, 30, or both of you watching Game of Thrones. is a proper Nash equilibrium. So this is how a Nash equilibrium looks like. So why are we discussing this? This is not the agenda. We wanted to talk about content creation. So this is the model which I have developed after a lot of brainstorming. Now, this would seem quite trivial, which it is, but just for the sake of it, just look at it once. Now, what's happening here is I have tried to form two agents, and this is not really a proper Nash equilibrium example, or we generally tend to call it strategic table or normal form table. But the idea here is we do not calculate a Nash equilibrium through this structure. But this is a way to calculate the equilibrium which I want to talk to you about. So let's say a creator, the creator could be a journalist, could be a comedian, could be a uh, YouTube channel host, could be anybody who is doing something uh, which other people are watching, reading, or things like that, or consuming basically. So the creator has two choices. Either he can attack a popular idea or a popular personality, or remain neutral. Now, why we are talking about this? What is the context? The context is, if you watch the news, if you watch your stand-up comedy acts, it is full of political ideology, and it is not always unbiased. So there must be some kind of an economic reason or psychological reason to it. So that's the kind of modeling which you want to do here. So let's say the creator has two choices, or two strategic choices: either to attack the popular figure, popular personality, or popular idea, or remain neutral. And society's sentiment can take a swing from ignoring the creator to giving him or her attention. Now, I'll detail what's happening here, but just to give you a quick idea, first thing is for creator, and the next thing is for society. So it's creator comma society. So the payoff structure is creators payoff, society's payoff, or creators notional value and society's notional value. So if society's sentiment is of ignoring the creator when he's attacking the popular idea or figure or personality, then you can look at here that the creator is getting 300 upon g minus 300. Now this g over here is greater than 1, which means he is getting something negative. Now over here society is also getting negative, which is minus 300. Now if they give him attention, he will, the creator would get something 300, let's say 300. And as the society is not a homogeneous one, if you attack a popular idea, let's say half of them would not like it, so half of them would like it and half of them would not like it. So taking a simplistic figure of 0 would be a good idea. The society gets 0. But let's say he remains or she remains neutral, then he's getting 300 by f, and some constant k is the notional value for society when they choose to ignore the content creator. Now again f is greater than 1. Now let's suppose the society thinks of giving the attention to a neutral content. Now in that case, the society as well as the creator gets 600 upon h, because it's a win-win for both of them. None of them are trying to get into a controversy. Now, as I said, FGH greater than 1, which ensures the structure of this table, and K is some known constant. Now, if you look at this thing, if H is less than 2, rather greater than 2, then this thing would be less than 300, and even this thing would be less than 300. So in that case, the equilibrium towards which the society will converge is the creator will attack the popular thing and sentiment of society will be towards giving him attention, and this is generally observed for upcoming or new creators. Because if h is greater than 2, what does this mean? This means that the neutral content of the creator is not getting sufficient attention, because this h is in the denominator, 600 upon h, which means neutral content is not favored, because if you increase h beyond 2, this decreases to less than 300. So society is not interested in this new creator. So what does the creator do? Creator attacks some popular figures, popular ideas, so that the society thinks about the creator, and this gives rise to this equilibrium which we have, the creator attacking the popular idea and society giving it attention. Now let's say h is less than 2. In that case, society is valuing the creator. Let's see what happens then. If society is valuing the creator, you can very well observe here that this thing over here, 600 upon h comma 600 upon h, is going to be a Nash equilibrium. Now why? To understand this, just take this number to be slightly greater than 300, because h less than 2 implies that. Take it 301. So if this is 301 and this is 301, do you think anybody can deviate from this position? If k is less than 301, then obviously society would not want to deviate if the creator is neutral. So society would not ignore, it will give attention. But what about k greater than 600 by k, 600 by h? In that case, this won't be an Nash equilibrium, because then society would want to move towards ignoring the neutral content. Now, what about the content creator? For content creator, if you look at it, 300 upon f is a positive number. So, if the society is choosing to ignore him, he would never go from remaining neutral to attacking, because this 300 upon g minus 300 is going to be a negative number. Similarly, if society is giving him attention, this 301 or anything more than 300 is more than 300. So again, he will remain neutral. So remaining neutral or creating neutral content is dominant strategy for the content creator. Dominant strategy is a strategy which is preferred by an agent for all situations, for all possibilities. Now, over here, we have tried to understand that this is not exactly a Nash equilibrium, but content creator would remain neutral. That is for sure. That's a dominant strategy for the content creator. Now, it depends on the society's structure whether they would ignore the creator's neutral content or give it attention. Now, when will ignoring be preferred? When k is greater than 600 upon h. Now, when this will happen? This will only happen when history of the creator is not good. He is one of those creators who has been in the limelight by disrespecting other people or attacking popular ideas in the past. So society would obviously want to ignore such creators. Now let's say k is less than 600 upon h. Now what does this mean? This means that the society is giving attention to the neutral content, which means the society is giving the content creator a reputation that this creator has never tried to hit any of the areas which are sensitive. So these are two societal structures which will be responsible for different Nash equilibria. But the underlying theme here would be that the content creation would be neutral. So whenever h is less than 2, or rather whenever society is interested in a creator or when he becomes an established creator, he dishes out or produces neutral content. This is the main conclusion here. And if we jump back to the earlier case of upcoming creators, now if h is greater than 2, we know that this thing 600 upon h would be less than 300. So in that case, this 300 uh, number is a very critical number because 600 upon h is always lesser than that. So if I talk about the Nash equilibria of this situation and think of the attacking the popular idea by creator and ignoring the content by society. Now, if we take this as a candidate Nash equilibrium, now given the creator not moving to any other thing, he creates a similar kind of content of attacking the popular figure. Society, if moves from minus 300 to 0 or ignoring to giving attention, would be a gain for society. So definitely this is not a Nash equilibrium. Now what about 300 comma 0, in which the creator is attacking the popular figure or idea and society is giving attention? So in 300 comma 0, if the creator deviates from attacking to neutral, he goes from 300 to 600 upon h, which definitely is lesser. So creator will not move. What about society? Society will never go from 0 to minus 300. So even society would not move. So 300 comma 0 or creator attacking a popular idea or figure and society giving it attention is a Nash equilibrium for upcoming creators. And similarly, for established creator, creating a neutral content is a dominant strategy. And the outcome, Nash equilibrium, would be dependent on the structure of society and history of the creator. So this is it for this video, and I know this was a bit messy. I'm trying to set up my video taking capacity. And I would also be writing a blog post on this to give a proper clarity very soon. So don't forget to subscribe if you liked it, and please like the video. And yeah, I'll see you tomorrow on Friday vlog. Thank you. Bye bye.